Good afternoon, my name is Bondan Dwisetyo. I'm from Badan Standarisasi Nasional BSN. Today I would like to present our research with the title of the realization of noise dosimeter calibration based on percentage of noise dose exposure using absolute method. The outline of this presentation consists of the background, purpose of the research, methodology, result and discussion, and conclusion. We start from background. Noise in a workspace. Noise in a workspace, it can produce from the factory, construction, laboratory, and traffic. And according to SNE 167063/2004, permissible noise for worker in loudness area is 85 dB per 8 hours. But about 73% of workers have been exposure noise exceed the limits. And of course, it can make a physical effect, physiology effect, and psychology effect. And it is necessary to be monitored by using a specific instrument that we call is a noise dosimeter. Noise dosimeter usually utilized by a worker in a loudness area. The function to survey noise in a specific area and then to monitor loudness in a workspace, and the function similar with the sound level meter. And then what is the beneficial noise dosimeter compared to sound level meter? Of course, more convenient to be used, or user-friendly, and high portability, and it can measure percentage of noise dose exposure directly. This is the main parameter or main measurement of dosimeter that we cannot find in sound level meter. The question is about this parameter, how about the accuracy, stability, and traceability? To assure the eligibility and reliability of noise dosimeter, and also to maintain the traceability chain of acoustic measurement, this instrument is necessary to be calibrated periodically. But problem is the calibration service related to percent dose parameter is not realized in Indonesia. In addition, a number of calibration service for noise dosimeter is very limited in Indonesia. So, this encourages us to conduct the research with the purpose is to realize the calibration of noise dosimeter based on the percentage of noise dose exposure, where scope of this research is limit for the parameters that consists of the percentage of noise dose or percent dose and time weight average TWA as the optional parameter, with the frequency range of measurement start from 125 Hz to 8 kHz with 1 octave interval. Basically, this calibration can be conducted by comparing parameter between standard instrument and device under test or noise dosimeter. For the standard instrument, first we measure of sound pressure level first, and after that this measurement will be converted to dose in unit percent, and after that for the device under test or DUT, it indicate or read percent dose and TWA parameter directly, and after that from measurement that indicate of both this instrument, we get the deviation value, and after that from this deviation value we compare it to the acceptance limit that required by standard. The method that used in our research is absolute method, where this is considered as a primary method for noise dosimeter calibration, having small correction factor, low noise and total harmonic distortion, small uncertainty measurement, and can produce a sound pressure level that derive from 1 Pascal. And to realize it, we need a laboratory standard of microphone as the primary standard for the acoustic measurement and calibration, and a full anechoic chamber. And this is a apparatus that support the calibration of noise dosimeter. This is in control room, contain the signal generator, power amplifier, conditioning amplifier, and sound analyzer. Meanwhile, in the inside full anechoic chamber, there are a loudspeaker and a microphone and or a noise dosimeter. Where in this research we use two noise dosimeter based on its grade. Class 1, or later we call it as a DUT1, and class 2 or DUT2. This experiment consists of 3 steps. The first step is determination of SPL using system calibration, where this is a determination of the absolute SPL, where the ref microphone is connected to the system, and by refer to the certificate calibration of sensitivity of microphone, the output voltage can be determined for each frequency. After that, this output voltage of each frequency will be produced using loudspeaker to microphone. And after that, by record the digital replace a microphone with noise dosimeter with at same distance to loudspeaker and floor, we can compare the dose that determined by using a microphone and the dose that indicate by noise dosimeter. The result is show deviation of the dose percentage between the standard and the DUT. This curve have a tendency to rise up to maximum value at 8 kHz, where its value are 2.2% for DUT1 and 3.7% for DUT2, respectively. Meanwhile, the acceptance limit that required by the standard is 5%. It means this value are still below the acceptance limit of that required by the standard. So this is still acceptable. And for the optional parameter that represent by time weight average or TWA, we also obtain the deviation between standard and DUT, where for DUT1 the maximum value it is found at the 4 kHz, where deviation value is 2.4 dB. Meanwhile, for the DUT2, the maximum value is found at the frequency of 8 kHz, with the maximum deviation is about 4.1 dB. Meanwhile, the acceptance limit deviation is 5.6 dB. So this value is still acceptable because still under the acceptance limit deviation. The conclusion of this research is the calibration of noise dosimeter based on the percentage of noise dose exposure has carried out using absolute method with at the frequency range of 125 Hz to 8 kHz with 1 octave interval. And the obtained deviation value between the standard and DUT still below to acceptance limit of value. And generally, the result of class 1 of noise dosimeter tend to has a smaller deviation, exclude at frequency of 1 kHz, where in this frequency the deviation is same between DUT1 and DUT2. This research is necessary to be continued for the other parameters such as long-term stability, linearity, and time-burst response, where for this parameter are still under implementation. And in addition, after obtain all the parameter, the evaluation and analysis of uncertainty measurement related to this research also need to be conducted comprehensively. Thank you for your attention. Thank you.